This lesson is on pressure conversions. So let's first talk about pressure. So we have the definition that it is the force divided by the area. But when we're talking about gases, like what is it? So let's say we have some kind of container. I don't even know, it can be any kind of shape. And we have a gas in our container. So we'll just designate that by little dots. So we know from the kinetic molecular theory that these particles are in motion. So they are traveling in straight lines until they hit another particle or they hit the sides of the container. So this particle could be traveling, hit the sides of the container, bounce off, travel until it hits another particle or the side of the container. So our particles are just traveling around. So these particles, when they are moving and they hit the sides of the container, anything that is moving and has mass, when it hits something, it exerts a force. A force is a push or a pull. So these particles, they are pushing out to the sides of the container. So the pressure, this results from the bombardment on the sides of the container from the gas particles. So pressure, this results from the bombardment of the gas particles, could be atoms or molecules, on the sides of the container. And our particles press evenly on all sides. So there's a pressure up, a pressure over, pressure down. Anywhere there's a surface on the container, our gas particles are pressing outward. And we also have, on the outside of the container, we have the atmosphere. So our atmosphere, we have molecules of nitrogen gas and molecules of oxygen gas and other gases. So the atmosphere on the outside of the container is pressing on the surface of the container on all sides. All right, so that is what pressure is. Now let's get into our units of pressure. So just like if we have length, we have meters, we have inches, we have centimeters, we have different units for pressure. So in your notebook, leave a space over here. We'll fill in the numbers after we go over what the different units are called. So our first unit is called the atmosphere, abbreviated ATM. That is called the atmosphere. And this is a unit, which might be confusing. We're not talking about the atmosphere. We're talking about a unit of atmospheres. Another pressure unit is mmHg. This is millimeters of mercury. And that comes from the first barometer was made with mercury, and the atmosphere pressed down on a pool of liquid mercury, and the mercury rose up in a tube, and they measured how far the mercury went. And that is where this unit comes from. There is another unit called the torr, and that's just the torr. So they took the millimeter of mercury and they renamed it after Evangelista Torricelli, who was the one who invented the barometer. So if you come up with something really great and innovative, maybe they will name a unit after you. All right, our official unit for pressure, the SI unit, is the kPa. This is kilopascal. kPa. So this is our SI unit. That's the official unit. And then we also have PSI. This is an English unit, and PSI stands for pounds per square inch. So we know that pressure, what do here? Pressure is force over area. So in this system, the force is the pounds, and the area is inches squared, square inch. So all of these are our units. Now, we'll define the unit of 1 atmosphere, and we're going to say exactly 1. That is the air pressure at sea level at 0 degrees C. So they just took that and they said, we're going to call that 1 atmosphere. Just like you could take the king's foot and say the length of the king's foot is 1 foot, and you measure everything else relative to that. Well, that's what we're doing here. We're defining the atmosphere as the air pressure at sea level at 0 degrees C, call it 1 atmosphere, and then all your other measurements are relative to that one. 1 atmosphere is the same pressure as 760 millimeters of mercury. These are equivalent. We could write a conversion factor for that. The torr is also 760. They just renamed the millimeter of mercury a torr, but it's the same value. For kilopascal, 1 atmosphere is the same as 101.325. And for PSI, our number is 14.7. So we can pick any 2 of these and write a conversion factor. So there are 14.7 pounds per square inch in 1 atmosphere of pressure. Okay, before we get into doing pressure conversions, we're going to quickly go over what do we mean by STP. STP is an important abbreviation when we're talking about gases, and this stands for standard temperature. And pressure. So scientists just got together and they said, we want to have a standard so that when we report our data, when we report it in STP, we can directly compare our results. So the standard temperature, and they just picked this arbitrarily, is 0 degrees centigrade. And the standard pressure, they picked 1 atmosphere. Could have been anything, but that's what they picked. Now, 0 degrees centigrade, that is the same thing as 273 Kelvin. And that is the same as 101.325 kilopascals. So whatever unit that you choose, it has to be the same as 0 degrees C, and your pressure has to be the same as 1 atmosphere. Then you are at the standard temperature and pressure. Oh, let's go back. I want to talk about the sig figs. Let's go back to this list. So for sig figs, this is exactly 1, exactly 760, exactly 760. So when you use these in a conversion factor, unlimited sig figs, here 6 sig figs, and here 3 sig figs. Okay, let's do a conversion factor problem. Okay, according to Weather Underground, the atmospheric pressure is, so I looked this up, and for brick, it was 30.24 inches of mercury. So that was the pressure when I looked it up earlier today on the site Weather Underground. So we're going to see how many millimeters of mercury that inches of mercury is equivalent to. So we're just going to use dimensional analysis. So our question is, how many millimeters of mercury? So that's our X. So X, M, M, H, G. Set that equal to our quantity of interest, 30.24 inches of mercury. Multiplication sign and crossbar. Now, even though this is a length, inches of mercury is a pressure, but we still have the same length conversions when we do pressure. So 1 inch of mercury is the same as 2.54 centimeters of mercury, because there's 1 inch in 2.54 centimeters. So we can cancel out our inches of mercury. We need another multiplication sign and crossbar. We have to get from centimeters to millimeters. If you remember the rulers that we used, the numbers were centimeters and the little tick marks were millimeters, and there were 10. So there are 10 millimeters of mercury in 1 centimeter of mercury. Cancel, cancel. We have the units that we're looking for. Put in our equal sign and our unit millimeters of mercury. So let's see what our pressure is. So 30.24 times 2.54 times 10 equals. So we have, let's see, 4 sig figs. This is exact, and that's exact, so we'll go with 4 sig figs. So 768.1 millimeters of mercury. So this is a normal atmospheric pressure. And in our classroom, we have a barometer at the back of the room, and it gives us information in terms of millimeters of mercury and also inches. All right, let's do another conversion. An automobile tire has a pressure of 36 psi. What is the pressure in atmospheres? All righty, so X ATM equals 36 psi, multiplication sign, crossbar. And then we just look at our list of pressure units, and we see that there is 1 atmosphere for every 14.7 psi. Cancel, cancel. We're finished with conversion factors, our unit atmospheres. Do the math. 36 divided by 14.7 equals. Okay, and we want to look for sig figs. 2 sig figs, 3. So we go with 2, so 2.4. So normal atmospheric pressure, the air pressure is usually around 1, and so this is about 2.5 times more than the atmosphere that's in your tire. Okay, let's do another one, and for this example, we have a bicycle tire. So our bicycle tire has a pressure of 500 kilopascals. Convert to atmospheres. So we just saw what a car tire was. Now let's see what a bicycle tire is. All right, so X atmospheres equals 500, and see that decimal point there? That's important for sig figs, kilopascals, multiplication sign, and crossbar. Check our list of pressures, and we see that 1 atmosphere, and that's exactly 1 atmosphere, is equivalent to 101.325 kilopascals. Cancel out. We have the unit that we're looking for, and we just do that math. So 500 divided by 101.325 equals. Check our sig figs. The decimal point means that we have 3 sig figs. That's 6, so 3 we need, so 4.93 atmospheres. So our bicycle tires have a higher pressure than car tires. And of course, this depends on what kind of bicycle you have. I have a beach cruiser, and that has a lower pressure than that. But if you have a road bike, you might have your tires inflated to a higher pressure than that. All right, we'll just do one more real quick. Okay, a gas in a rigid container has a pressure of 1145 torr. How many kilopascals is that equivalent to? All right, X kPa equals 1145 torr times, check our list, there are 101.325 kilopascals in every 760 torr. Cancel out the torr. We have the unit that we want. Do the math. Oh, check sig figs. 4 sig figs, 6, that's unlimited. So our answer should have 4 sig figs. 1145 times 101.325 divided by 760 equals, and we have, what did I say, 4 sig figs, 152.7 kilopascals. And we just want to keep in mind around 100 is what a normal air pressure is, so it's about 1.5 times what the atmosphere produces. All right, so that's it. Easy as that.